Okay, double integrals in polar form. In 1 and 7, describe the given region in polar coordinates. So just real quick, we look at this just to get a feel for it. So one of these would present a graph like this. You can easily tell it's going to be pi halves to 2 pi because it's like 3/4 of a circle from this coordinate. It's literally just a circle imposed on xy coordinate plane. And polar coordinates are based on this circle and all that. And 0 less than equal to r less than equal to 9 because it goes all the way up to a radius of 9. And that's kind of what this whole is, just to get an idea of how polar coordinates look. The region enclosed by the circle x squared plus y squared equals 2x. That's what you're given. And we know x equals r cosine theta, y equals r sine theta. X squared plus y squared equals r squared. We know these relationships. So we don't really need it too much, but it's nice to look at them like that. X squared plus y squared equals 2x, basically. It can be written as r squared equals 2 r cosine theta. So r equals 2 cosine theta because you divide by r. And you can draw it like this. You can graph it in a graphing calculator to get an idea of what it should look like. And it'll show that it's negative pi halves to pi halves, and 0 to 2 cosine theta for r. You can see it in a graphing calculator to some extent if you really can't understand how to graph it and all that. You just have to change the mode to polar coordinates, and you'll be able to graph in r and theta instead of x and y. But let's look at some. So we're going to be converting these integrals for the most part, for most of these problems, converting from rectangular coordinates to polar and solve an integral that way. So negative 1 is to x part and y is 0 to, negative 1 less than equal to x less than equal to 1 is x, is for x, and 0 less than equal to y less than equal to square root of 1 minus x squared. The y upper bound, the upper limit is basically can be rewritten as x squared plus y squared equals 1, which is a circle, and y equals 0 means only upper part of circle. Because its lower limit, 0 means that it's not going to be negative. So this is like the upper, means it's the y part just gives us it's going to be the upper part of a circle. And x is negative 1 to 1. So that means x values of negative 1 and 1, what it can be between, imply that we have an r equal 1. But it also, more importantly, implies that you can also get from that you have your x value is negative and positive, your y value is always going to be greater than 0 region. So it can imply that it's going to be 0 to pi. You say the value in negative, 0 to pi, because it's the upper half of a circle, but also fulfills the fact that x is negative and positive. You kind of have to relate this to the x and y axis sometimes like that. You'll see in other ones. So it's 0 to pi, 0, 1, r, dr, d theta. That's how you can write it, as the limits. And 0 to 1 is because, I think you can intuitively kind of guess as well from how it works, that it's going to be just stretching from negative 1 to 1. And it's a circle, so that works out very well. And then you can integrate this relatively easily. It becomes r squared over 2, and you do r equals 1 and r equals 0, so eventually you get 1/2 d theta. Becomes pi halves. That's all you do. The actual integration steps can be simple at times, so they can also be more messy as well. But it's still, generally speaking, when you use these polar coordinates, you're usually going to be having easier times than if you use the same original coordinates. Rectangular ones. So we have 1 the square root of 3, 1 to x, dy dx. I think this is actually one that you could probably integrate without doing it. I think this one would be actually pretty easy to integrate normally, but it's like for some reason we have us do it with polar. But regardless, you have your limits like before. And this time might as well graph it since it's easily graphed. It's this triangular region here, and this before, just to get a more of a feel for what's going on here. It's this region. It's not like a total circle or something where a whole quadrant will be taken or whatever. So we can't just because it's in the first quadrant does not mean. What it means is that we know what zeta will be in the range of, but we want to have exact values for what zeta can take on. The upper and lower limit for zeta. But one way to do this is the y equals x, which is the upper limit for y. We can take this as r sine zeta equals r cosine zeta, because that's what x and y are equal to. That means sine zeta equals cosine zeta. Eventually you get division of the two equals 1, so tangent zeta equals 1. That's what sine divided by cosine is, it's tangent zeta. And the inverse of that, of tangent zeta, the inverse of tangent of 1, tangent inverse 1, is zeta equals pi force. So, okay, that kind of gives us the upper limit since y equals x. As you can see from here is the upper part. What about the lower area? What about our lower? What are we supposed to do about that? Well, I suppose we use tangent of zeta equals y over x is one more relationship we can use, and 1 is from y equals 1. Oh, it's 2, and square root of 3 comes from x equals square root of 3. Right on it. As this will give you like the other end extreme, like y equals x was associated with this line here. So this part, that's why you want to include the integration area only. But if you work backwards and get your inverse tangent, it's inverse of 1 over square root of 3. It's pi sixth, because you can think of it like this. Sine of pi, like what sine and cosine thing? Sine divided by cosine, the two values, sine value and cosine value at a certain, at pi sixth will give you 1 over square root of 3 if you divide them. Because sine of pi sixth is 1 over 2, and cosine is square root of 3 over 2. So 1 divided by 2, 1 over 2 divided by square root of 3 over 2 is 1 over 2 times 2 square root of 3, because you flip them. So 1 over square root of 3. So it works out, and that's why the inverse tangent is. And we know that it's in the first quadrant, so it has to be. Can't be in the third quadrant. That's kind of why you still sketch them out the normal way. It's not as useful, it still has its uses like that. So pi 6 is less than or equal to the zeta, less than or equal to pi force. Y equals... But okay, so we have our zeta limits now. We plug in values to get our y equals r sine of zeta means that 1 equals r sine zeta. So we want to find r values, so 1 divided by sine zeta, so cosecant zeta. R equals cosecant zeta is one limit. And x equals square root of 3, so that's another important limit. Like it's the upper limits, we do it. But you get square root of 3 divided by cosine zeta eventually, because r cosine zeta equals x. So r equals square root of 3 secant zeta, because 1 over cosine zeta is secant zeta. So our limits are there, and then we can write the integral as pi 6 to pi force cosecant zeta, the square root of 3 secant theta, r dr d theta. You always use r dr d theta when you're converting. That's what dy dx becomes. What do you? So we have to solve this. And what we do for integration, it's r squared over 2, because that's what r is, the integral of just r is. We have to put in the limits. So you can simplify this down to 2. You're dividing by 2 and it's just squared. So 1/2 times the integral, you can take out 1/2 basically. And square root of 3 secant theta is just 3 secant squared theta when you square it. Square root cancels and cosecant theta becomes cosecant squared theta. And it actually works out good for us. Because of the fact that we have exact integrals for these. So it becomes 3 tangent theta, because secant squared theta's integral is tangent theta, and negative cosecant squared theta. The integral of cosecant squared theta is negative cotangent, so it becomes positive. This case. So you add cotangent theta. And we have theta equals pi 4, theta equals pi 6 limit, so we have to just solve for it now. Evaluate it at these points. And from trig, tangent pi 6 will be 1 over square root of 3. We had this at the beginning. Cotangent of pi 6 is just square root of 3 over 1, because cosine over sine instead of sine over cosine. And you evaluate it and you simplify things down over, and it's 2 minus square root of 3. Just check anything scan over 1. Okay, no. This one just a little bit odd angle. So negative 1 to 0, negative square root of 1 minus x squared to 0, 2 over 1 plus x square root of x squared plus y squared. Yeah. So it's easy to figure out what this is if you just understand. So x equals negative 1, x equals 0 will be that. So x is never positive. But more importantly, y squared equals 1 minus x squared. From this thing, y equals negative square root of 1 minus x squared. You can make this into eventually x squared plus y squared equals 1. So it's going to be a normal unit circle, radius 1 and all that. And it fits perfectly with what we want. We can burn the polar coordinates, we can easily do it here. It's a third quadrant, so that means that it's pi to 3 pi halves. And that's all you have. And 0 to 1 is your r. Because it's still the arm, the pole, I think is what it's called. The pole of the polar coordinates. Whenever it's like an arm reaching out and swiping with the angle. Oh, and you have to convert this real quick in pink. So 1 plus this radical, the square root of x squared plus y squared. It's 1 plus the square root of r squared, because x squared plus y squared equals r squared. So it's just simplifies down to 1 plus r. So the integral is 2 over 1 plus r times r basically, and then dr d theta. It's pi to 3 pi halves, 0 to 1. Then you solve this. I multiplied in r, and this one you have to think a little bit about how to solve. You have to do U substitution with some tricks, a little bit more trickier than normal, like if you don't off the top of your head. I mean, ugh. You just have to remember you can sometimes do it like this. So you let u equals 1 plus r, so du equals dr. Problem is, you still have 2r to worry about, so you have to let 1 plus r. So 1 plus r equals u still. That means that r equals u minus 1. And you have to sub in for, you want everything to be in terms of u. So you have 2 times u minus 1 divided by u du. D theta. Yeah, and it's these integrals. So it almost, oh yeah, and r equals 1 means u equals 2, r equals 0 means u equals 1. So I've shifted even that in. So it's multiply into 2, it's 2u minus 2 over u du d theta. You can split it up and eventually get 2 minus 2 times 1 over u du d theta. And the integral of 2 is 2u here, and 2 times 1 over u is 2 times ln u, because the natural log is the integral of 1 over u du. And then u equals 2 and u equals 1 is what you have to integrate with. So the limits of integration. You plug them in, you use ln 1 is going to be 0. ln 2 we just keep as that. You eventually get 4 minus 2 ln 2 minus 2, and you have to do d theta. Simplify down before 2 minus 2 ln 2. So it's 2 theta minus 2 ln 2 theta, and you have to take the limits now. Eventually, it's pi minus pi ln 2, which is equal to pi times 1 minus ln 2. You're going to divide out the pi, so it's just 1 minus ln 2 times pi. And that's the answer. And 19. Okay, so we have to convert this 0 to ln 2, 0, that mess in there, parentheses, e to the square root of x squared plus y squared dx dy. So we have to convert this to polar. This one's not extremely hard either. And I make a terrible graph, but it is a circle again, with ln 2 being the radius. So limits is, you do it again, you get x squared plus y squared equals ln 2 squared. And that's a circle, unit circle, radius ln 2 and stuff like that, centered at origin, all that. So the arm is 0 to ln 2. And the quadrant is just the first quadrant basically. X equals 0, and this positive, it's a positive circle, so it's going to be just the right side of the circle, all that. 0 to it. 0 is the lower limit. So 0 to pi halves, and e to the square root of x squared plus y squared becomes e to the square root of r squared, which means it's e to the r. Oh, so this looks easy to solve, right? Not exactly. We have to do an old trick, but we'll see in a minute. So 0 to pi halves, 0 to ln 2, e to the r, e to the r times r, dr d theta. Integration by parts comes back. Yeah, integral of u dv equals uv minus integral of v du. Yeah, and it's the point is up here is what you get. You get r e to the r minus e to the r. R equals ln 2 r. So yeah, that's what you have to plug into. That's what the first integral becomes. So this work. It's r times e to the r minus integral ln 2's 0 to e r dr. And that's because you do u equals r, and that means the derivative du equals dr. Then you have to find dv is equal, you have to set that equal. So u equals just usually a simple, a small expression, and dv is everything else. So it's equal to r in this case, r times e to the r dr. So it's r. Then dv has to be everything else, so that's the e to the r dr. Then v is the integral of e to the r dr, so that's just e to the r. It's a very simple integration by parts if you know how to do it. Integration by parts. You just have to recall how to do it, and especially when they use it like this. So integral e to the r is just e to the r, like I've said before. So you have to plug in r er minus er. You have to plug in ln 2 and 0. Do your normal stick. You do the normal sequence of events, and you end up with 2 ln 2 minus 1 d theta. And that's just 2 ln 2 theta minus theta. And you integrate. Then you simplify down further with evaluation. and then you can divide out here pi half. So pi ln2 minus pi halves, I divide out a pi, and the official answer wants pi halves divided out, so you get a nice 2 ln2 minus 1. Basically you're dividing out a 1/2, so ln2 divided by 1/2 is 2, and 1/2 divided by 1/2 is 1. That's what you're doing, so it's pi halves times 2 ln2 minus 1. But I'm pretty sure this answer is completely fine by almost everyone. Pi times ln2 minus 1/2. Okay, so here's an easier way. We get polar coordinates, we want to go to x and y coordinates rectangular. And we don't solve it because it's going to be hard to solve in this type of integral. Or that. And I don't know if it would be extremely difficult compared to some stuff. But either way. So 0 to pi halves, 0 to 1 r cubed sine theta, cosine theta, dr d theta. So it's first quadrant from 0 to pi halves. And it's a circle with radius 1, center at origin. That's kind of what you can imply from this information. X squared plus y squared equals 1 in first quadrant. So y equals square root of 1 minus x squared will be your upper limit, because that's your curve there. So 0 to 1 is x, because obviously it's unit circle, radius 1, center at origin. And 0 because it's the first quadrant. 0. The first quadrant is like saying x equals 0, y equals, x equals 0, y equals 0 is your parameters. Is a new set. Either way. But x equals 1 is also because of that. So that's where 0 to 1 comes from, and then square root of 1 minus x squared is and then y equals 0 is the lowest thing, like I said. So 0 to square root of 1 minus x squared, and then it's xy, dy, dx, and xy comes from this. X equals r cosine theta, y equals r cosine theta, and r dr d theta equals dy dx. So r cubed can be split into, this thing can be r sine theta, r cosine theta, r dr d theta. Then you can easily convert yx or xy, or whatever order. You have to mind it for this though. So xy, dy, d theta, dx. Yeah. With respect to y first and x, so because y equals square root of 1 minus x squared, chooses a limit, so it has to be the first one. And finally, find the area of the region cut from the first quadrant by the curve r equals 2 times 2 minus sine 2 theta 1/2. You can graph this as a graphing calculator using polar mode and making sure you use r and theta as your setup. So you can see from that graph from 0 to pi 4, so 0 to pi halves is the first quadrant. And 0 is less than or equal to r, less than or equal to this. You can kind of deduct from that, but it's also kind of obvious, I think, if you look at the graph here. And you integrate, like before, r squared over 2, and you have to, there's no real tricks used, just normal integration techniques. You end up with 4 minus 2 sine 2 theta. Integrate that, and so it becomes 2 times the quantity pi minus 1, and that's it.